Alrighty, back again with another video. In this video, we'll be going over the quotient rule. There we go. Pen was acting up. So anyways, the quotient rule. Quotient means division, okay? Quotient means division. So here's an expanded form of division, okay? We got 3 to the 5th power, which is 1, 2, 3, 4, 5 threes. Also, we got 3 to the 4th power, which is 4 threes. The rule is when you have division, if you can cross it out on the top and the bottom, identical crosses, you can eliminate them properly. So here's one cross. Here's another cross. Here's another. Here's another. What's left behind is this 1 3, and this 3 is located at the top, which makes it like a 3 over 1. Y'all know the invisible 1. Here's the answer. All right. When in reality, y'all, all they could have did, well, I should say all they should have did was 5 minus 4, which is 1. All right. Meaning the answer is just 3. Nobody writes that 1. That's an invisible 1. So your rule, here's your rule for quotient. Your rule for quotient is subtract exponents. All right, that's what makes it special. You have to subtract exponents. They prefer top to bottom, but of course we'll do more practice. You can see that sometimes you can bend the rules, all right? And of course with the coefficients, I should have wrote this one first. You're going to divide coefficients because that's what quotient means. You're dividing. Quotient means divide, all right? So in this situation, we do not do 3 divided by 3. These are not considered coefficients. These are bases right now, okay? These are bases. So the base is going to stay the same, okay? Base will stay the same. Anyways, let's get into some problems. So right here, here's an example that we can use the quotient rule for. And now, the rule is only x's with x's. So when I write these two on top of each other, oh, that's not a 3, should be a 2. And for my y's, I got y to the 11th and then y squared. And for my z's, I only got z's at the top. Well, let's pick up purple. Z to the 3rd. In reality, what we're doing is top minus bottom. The rule is usually top minus bottom. So 3 minus 2. And for the y's, it'll be 11 minus 2. And for the z's, nothing because no z's are here. Like z to the 0 power. Anyways, that would be a waste of time to put 3 minus 0. The only simplifying we're going to do is here and here. 3 minus 2 is 1. And 11 minus 2 is 9. Here will be your final answer, okay? Of course, you can use the information here to kind of categorize how this works. But this is how it looks, y'all. This is how it looks. This is one version of how it looks. We can also do the expanded form if we wanted to, which means we got to write 3 x's, 11 y's, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 3 z's. And on the bottom, 2 x's, 2 y's. And we can follow those rules where we cross out. By. Only 1 x is left at the top. U. Only 9 y's are left at the top. And for my x's, I don't cross any of them out. I got 3 left. So, answer from here would be a single x, 9 y's, and 3 z's with nothing on the bottom but an invisible 1 that nobody writes. This is called the expanded version, okay? This is the expanded version. This is just us following the rules down here. This is just, top minus bottom on our exponents. And then the game eventually becomes more difficult. How? They include coefficients. So for this problem, we got 12 and 6. All right, 12 and 6. In the calculator, we can just type in 12 divided by 6, which is 2. All right. And for our x's, we're going to do top minus bottom, which is 3 minus 1. And for the y's, top minus bottom, which is 1 minus 3. Final answer, you should get 2 x squared y to the negative 2 power. Womp, womp, womp. Can't have a negative exponent. He's not happy. Make sure you move that downstairs as y squared. Got to move him downstairs, all right? Now, that's just that form. I can do the super expanded form, and this is how you deal with the 12 and the 6. When you're working expanded form, it's best to break down 12 to its tiny little pieces. 12 is disguised as 2 times 6, and 6 is really 2 and 3. So in reality, 12 is 2, 2, and 3. 2, 2, 3. And 6 is 2 times 3. That's what we got right here. 6 is just 2 times 3. And now I can throw in my 3 x's, 1, 2, 3, and my single y. And on the bottom, I got my single x and my 3 y's, 1, 2, 3. Then we can start playing the game of elimination. So I got a 2 up top, 2 on the bottom. I can cross those out. I got a 3 on the bottom and 3 on the top. I can cross those out. What's left is a 2 up top. Easy money. For my x's, I cross him out, I'm left with 2 at the top. That is x squared. And for my y's, I got cross him out. I am left with 2 at the bottom. Guys, listen. We can avoid the negative completely using the expanded form, okay? Now, by using the expanded form, I really suggest that you break down your coefficients to their tiny little pieces so that you can expand those same rules that we have with our exponents as far as crossing them out. We can expand those rules over to the coefficients. Bam, 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 bam. If you're on the top and you're on the bottom, we can eliminate you because that neutralizes to an invisible 1, a 1 that nobody writes. And the fortunate situation up top is that we don't have any negative exponents to deal with like this. Sad situation. Everything just works out the way it should. Again, this technique is for the motivated student because it's a super crawl. You are crawling. You can't be lazy up here with the expanded form, okay? Can't be lazy. In your notes here, they do a deeper breakdown. Again, if this is how you want to get down, cool. I'm just here to add suggestions. Let's go ahead and go to our next situation, some guided practice. Ooh, this one in the middle looks like a lot of work. I'm going to do this one using the expanded form. Oh, yeah, it's going to be a lot of work. Now, if you want to, you can go off to the side and do your own breakdown. I know for a fact that 21 is just 3 times 7. That is the breakdown of 21, 3 and 7. And then 8 A's, 1, 2, 3, 4, 5, 6, 7, 8. 3 B's, 1, 2, 3. 15 C's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. A lot of work, but I'm not lazy. Now on the bottom, 7, we don't even break 7 down because it breaks down to itself, 7 and 1. Don't waste your time. For the A's, we got 3 of them. For the B's, we got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for the C's, we have 2. This is what we have all the way, all right? Everything is accounted for. For my coefficients, I got the 7s left. They're gone, all right? For my A's, you're gone, you're gone, you're gone, you're gone, you're gone, you're gone. I am left with 1, 2, 3, 4, 5 A's, and they're up top. For my B's, you're gone, you're gone, you're gone, you're gone, you're gone, you're gone. I'm left with all these B's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 down here. And then when I cross out 2 of these C's on the bottom, 2 up top, I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13 of those bad boys left. This is all the math that's done now. This answer right here, literally, is going to be 3a to the 5th and c to the 13th. All of this is going to be up top. 3. I'm sorry, I'm writing down here. Clearly, I used the expanded form, so I'm running out of space. We got a to the 5th. None of the b's are still up here, all crossed out. And then for the c's, we have 13. On the bottom, we're left with 9 b's. So b to the 9th. No c's are left, no a's are left. This would be my final answer, the expanded form. Some of you may think this is excessive. Guess what? This is for the motivated and the unlazy, okay? That's what it's for. The expanded technique is for the motivated and unlazy. And there's somewhat of some organization to this skill, but it is what it is. Some of you are probably thinking, hey, couldn't you just type in 21 divided by 7 and get 3? Yes, you can. Just know that that 21 divided by 7 always goes up top, never on the bottom, okay? Even when you type this into the calculator, whatever you get, it goes to the top. I'm pretty sure in the calculator you get 0.5. Whatever, who cares, all right? Make sure it goes up top if you're going to just type in the calculator what the coefficient is. But we will get extra practice staying away from decimals and using simplified fractions. Don't get mad at me. It's the game, okay? Anyways, I'll do this one here. For my n's, I got 1 n and 4 m's. 1, 2, 3, 4. 2 n's, 1, 2, and 7 m's. 1, 2, 3, 4, 5, 6, 7. Now we do the cross-out game. You're gone, you're gone. 1 n is left. 1, 2, 3, 4. 1, 2, 3, 4. I got 3 m's left on the bottom. My final answer, if I'm using this decimal, would be 0.5. That's the only thing up top. 1 n and 3 m's on the bottom. Also, it's equivalent, but we don't like it, all right? It's kind of not beautiful. It's not a beautiful situation. Now, how I would prefer you deal with this 3, 3 can't be broken down, but 6 is disguised as 2 times 3, okay? 2 times 3. I can cross out both 3's, and that just means there's a 2 on the bottom and an invisible 1 up top. So 1 over 2, the m and 3 n's. This would be the equivalent, okay? This would be the equivalent. Any questions on that? And now, one thing for our notes right here, domain restriction. When you have a variable in your denominator, it cannot, that's the equal sign with a slant, cannot equal 0, okay? Cannot equal 0. All right? So for the 2 problems that we just worked, so this one right here, yes, this has a restriction. This has a domain restriction because it had a b at the bottom. We're going to say b cannot equal 0, okay? I don't know how good your calculator game is, but if you take any number and divide by 0, it's going to say undefined, okay? Even with this bottom situation, we're going to say that there's a domain restriction. How do we know? Because we have n and m at the bottom. N cannot equal 0. M cannot equal 0, okay? We cannot have any variables at the bottom that's going to equal 0. Anyways, after working this problem out, I will say that these are going to cross out. 3 minus 3 is 0. 9 minus 3 is 6. All right, so in this situation, you wouldn't have any t's at the bottom. Let's say I do not simplify, but you will. you'll have t to the 6 at the top, okay? The s's are going to stay because nothing there. As you can see, there are no variables in the denominator. So you're going to say there's no restrictions, okay? Only when there's a variable at the bottom will you have a restriction. So anyways, let's move on. Now we got some power of quotient, all right? Power of quotient. Let's get into these examples. I'll go to a mirror situation here. A mirror situation looks like this. You see the power rule that we learned in the previous lesson? Remember, it's going to go here to the 7, it's going to go to the C, and it's going to go to the R. They're all considered bases. And another way, you can just rewrite this thing 7 times. I mean, not 7 times, but 3 times. So 7C times R, 7C divided by R. To the third power means 3 separate times. So follow some rules. 7 times 7 times 7. You end up with, typing into my calculator here, 7 times 7 times 7. You end up with 343. And for my C's, I got 1, 2, 3. We got 3 C's. And on the bottom, we got 1, 2, 3 R's. All right, this is what this thing would simplify to. In reality, you could have did it all right here. 7 to the third power, C to the third power, R to the third power. Because all of these folks are inside the parentheses as bases, they all get parentheses, okay? That's how you can get rid of the bigger parentheses. And then everybody just gets the 3 on the outside. Bam, bam, bam. So the only thing you would be typing in the calculator is this guy, which again is the 343 C to the third and then R to the third. Easy money, whatever floats your boat. Again, this is us expanding the product power rule to product. All right, you see those little dots right there? That's called multiplication. So we expanded power rule into product rule. Did a little breakdown, and it just happens, man. It's a beautiful thing. Again, most students forget to do this last piece right here. Don't you forget it. All right, don't you forget it. So anyways, the last problem we just did, we ended up with 3, 4, 3, C to the third, R to the third. Would this have a domain restriction? Yes. We have a variable at the bottom. R is at the bottom. R cannot equal 0, okay? That's how domain restrictions work. You cannot have a 0 in the bottom of your denominator. It's an undefined situation. Let's continue. Got the little matching situation, then your turn. I could do more problems, but maybe it is time for you, the student, to work. Maybe it's time for you, the student, should do some work. What do you think? Yeah, let's end it here. Again, come to school, be actively paying attention, and of course, actively ask questions during the lesson.